When looking at like graphs of linear equations, you have the y-intercept or the initial value or what's called the starting value. So we're going to first talk about just the y-intercept. Anytime a question may say like, what is the y-intercept? What is the initial value? What is the starting value? It's all talking about the same thing. And it's talking about the point where the graph intersects with your y-axis. And the most important thing you need to know is which axis is which. So your y-axis is the vertical axis. Your x-axis is the horizontal axis. A lot of people have sayings that help them remember which axis is which. The one that I'm familiar with is y to the sky. So it rhymes and it kind of reminds you that it's the one that goes up and down. So I think that's helpful. Now, today you're like, okay, well, what's the point? We're going to look at some real world graphs, look at the y-intercept and talk about what does that value actually mean in the context of that graph. Let's take a look at this graph. Our y-axis is talking about total meals packed, and our horizontal axis is talking about time in hours. We want to see where that red line is going to cross the y-axis, which is our vertical axis. Right now, the graph is zoomed in on quadrant 1. And what I mean by that, if I extend my axes, where this is my x-axis, and this one's my y-axis, so now you can see all 4 quadrants. And just kind of as a review, like this was quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Where my red line is going to intersect with my y-axis is right at the point 0, 0, which is called the origin. Now, that does not always happen, but it's possible. So our y-intercept in this case is 0. But the reason it's 0, and this is what's important, is because it's the y-coordinate of the point. So 0, 0, but it's specifically talking about the second value. Because a lot of times students are like, well, what does it matter if it's 0? It will whenever we have a different y-intercept. So when we look at our next example, you'll kind of see what I'm talking about. Then we can label these x, y. Now, we know that it's 0, but what does that actually mean? Our x is talking about time in hours. So if I label my point, so x is hours, and then y is talking about the total meals packed, number of meals packed. So if you understand like why I labeled it that way, then we could write a sentence using that information and say at the hour 0, there have been 0 meals packed. But that's a weird way to say it, because like who talks like that and says at hour 0? A better way, because we say like, what is the initial value? We could say the initial number of meals packed was 0. Or when we started, there were 0 meals packed. Something like that that's talking about like that is the beginning. So I'm going to write that out because I feel like if you see it and you hear it, that it'll help you remember. The initial number of meals packed was 0. Okay. All right. So our second example is going to be looking at an elevator ride. So in this case, again, if we look, like my y-axis, they already have it kind of extended, but you could extend it even further in my x-axis, and they have them labeled. So x-axis, y-axis. I can highlight my y-axis because that's the one that's important when I'm looking for my y-intercept. And then the graph is that blue line, right? So I could extend that blue line and then look at where does that yellow line and that blue line cross each other. So think about that in your head. And if you're thinking that it's crossing at the value 20, that would be correct. And that would be your y-intercept. And then the coordinates of that point would be 0, 20, because if you remember when you graph, you start at the origin, 0, 0, and then you move to wherever that point is. So you move right first or left, and then you would move up or down. Well, I don't have to move right or left at all because it's on that y-axis. So I'm moving 0 right or left, and I'm moving just up 20. So the coordinates of this point would be 0, 20. And that kind of goes with what I'm talking about, like that second value is always the y-intercept. So x, y. Y coordinate is the y-intercept when your x value is 0. I would label what those two things are. So my x-axis is talking about time, but specifically, like if I just write time, I don't know what the unit is. So it's time in seconds. So really what's important to me is the seconds. And then my y value is talking about the floor number. And then it's always important to look at the context of like, what is the overall graph talking about? Well, we're talking about an elevator ride. So we want to make sure that that's included in the sentence. Otherwise, you don't know what are you talking about, like the floor of what, the time of what. So in this case, because we're talking about a specific point, we could say, this is not the best way, but you could say at 0 seconds, the elevator is on floor number 20. But again, that's not really how you talk. So a better way would be to say that the elevator started on floor number 20, or the initial floor of the elevator was floor number 20. I think it flows better if I say the elevator started on floor number 20. And that kind of explains what that value means. So first part, identify what the y-intercept is, then look at your graph and figure out in the context of the graph, what does that actually mean? And your y-intercept is always talking about the initial or the start. Okay, we're gonna go to the next problem and I'll zoom in a little bit. So looking at that graph, what do you think is the y-intercept? So what's just the numerical value? And then if you get that figured out, then can you tell me, write a sentence to tell me what that value means? So let's kind of talk through. So extend your y-axis, extend your x-axis, and then you're looking at where does your graph, so this is my graph, my line, right? Where does that intersect with my y-axis? So if it helps you, you can highlight the vertical axis is the y-axis. Horizontal is the x-axis. So now looking at that, where do they intersect? We are looking at where does that green line and that yellow line cross each other? Like where are they touching? They're actually touching at this point right here, which is at 300. So where do those cross? Or like if you extended that green line even further, that would be at the point 300. And then again, with the coordinates of it, if we started at the origin, so our origin is right here at 0, 0, but then I'm not moving right or left at all to get to that red dot. I'm just moving up. So what that means is my x coordinate is 0 because I don't move right or left. And then I already know that it's at the value 300. Then once you see where do they cross, now let's talk about what does that actually mean. So 300 what? X is talking about months. And then my y-axis is talking about the number of dollars in the savings account. So I'm just going to use the money sign so I know I'm talking about money or dollars. Now the other piece that you want to keep in mind is the title. So we're talking about money in the months for John's savings account for the year. So one way, if we take that information, we have 0 month. So at month 0, John has $300. You could write it like that. I'd probably accept it, but it's not the best way, right? So if we're talking about the start or the initial, we could say at the start of the year, John had $300 in his savings account. That would be a great sentence because it flows. It's how you would talk. Or you could say the initial value of John's banking account was $300. Perfect. Like if the message is clear, so if you did write it the first way, like at month 0, John had $300 in his bank account, I would accept that and we would just work on that. Like, how do we make it sound better? But if your information is there, that's good. Take a look at this one. What do you think is the y-intercept? Make sure you look at the scale of the graph. And then keep in mind we can extend the X and Y axis if that kind of helps give you a better visual. And one last thing to kind of help you, if I highlight my line, so where does that yellow line and that green line intersect? They're intersecting at the value 25 because that point is between 20 and 30. So you need to figure out what the scale is and it's going by 5s. The y-intercept is 25. And then the coordinates of that point, as always, the x value is 0. So it's 0, 25. Our x coordinate is talking about the number of coffees, right? So x-axis, what is it labeled? Our y-axis is talking about money again, so dollars. And then the last thing we need to pay attention to, especially in this problem, and I'm going to explain why, is the amount on the gift card. Because if I don't acknowledge that, I could say, if I have 0 coffees, I have $25. But then it's like, what does that mean? Like, I didn't buy any coffee, but I paid $25? No. So in this, we're talking about money on a gift card. So you want to give it context and say, if I have bought 0 coffees, I have $25 on a gift card. That makes sense because that means none of the money was taken away. Or a better way would be the starting amount on the gift card was $25. Okay, so part of your assignment, the first part of your assignment would be looking at graphs and identifying y-intercepts. And some of the questions will then give you some multiple choice, like what does that actually mean in the context of the graph? And you'll have to choose the statement that's talking about the starting value, the initial value with the correct number in the correct context. So make sure you're paying attention to what's your x-axis, what's your y-axis. As far as y-intercepts, I got 2 other short little problems. Looking at this graph, what is the y-intercept? This one's your y-axis. So if you said 4 or you're thinking 4, that is correct. And then the coordinates would be 0, 4. The reason I tell you the coordinates over and over again is because sometimes the question will say, just what's the y-intercept? And if you say 4, great. Or if it says, what are the coordinates of the y-intercept? You need to know that. And especially as we move forward and get into more advanced stuff, you'll need to know that those are the coordinates for some of the problems that we'll do. Okay, one more example. Pay attention to your axes. What is the y-intercept? Y-axis is our vertical axis. Where does that intersect with our blue line? It's intersecting at this point, but what we should notice is that point is below my x-axis, so I have to go down to that point. So my y-intercept is at -2. The coordinates would be 0, -2. Okay, and then there's no sentence or anything that goes with it because we don't have labels for x-axis, y-axis. We don't have a title. If you did, you could still do that. Now, last thing for today is about rate of change, which is also known as slope, which is also known as gradient. Gradient is typically talked about in like higher level classes, but we want to introduce it now because they're all the same thing. So if it says, what is the rate of change of the graph? It's asking the same thing if they said, what is the slope of the graph, which is asking the same thing as if they said, what is the gradient of the graph? It's just 3 different terms for the exact same thing. And what that's talking about is the steepness or the rate at which the graph is increasing or decreasing. So if it's a super steep line, it's going to have a greater rate of change than something that's closer to being horizontal. And how you calculate it is you take the number value of the vertical change and divide it by the numerical value of the horizontal change. So your change in your y values divided by your change in your x. And then the last piece that I want to point out is this little triangle. You should see that in your science class. It's called a delta. So delta means change. So a lot of times you see like delta T for the change in temperature. Same thing in math. Okay, so you could find your y-intercept for this as well. So if I extend these, and so my y-intercept is right at 0, 0. And then in order to find my rate of change, so my y-intercept would be 0 or the point 0, 0. I need 2 different points. So I'm going to use those 2 blue dots to figure out how much is it increasing. And you're going to just count. So there is an equation. I don't know if you guys remember, y2 minus y1 divided by x2 minus x1. We'll talk about that eventually. But right now, all you have to do is count it. So starting at 0, if I want to get up to the other blue dot, I need to go up to get to the other blue dot. And by how much? Well, from 0 to 10, I'm going positive 10. And my formula is the change in the y divided by my change in my x values. Well, my change in my y is 10. And then if I then go to the right, right is positive, left is negative. So if you think of a number line, you have 0 in the middle, the numbers to the right get bigger or positive, the numbers to the left of 0 get smaller or are negative. So it's the same thing with the direction. So I would go positive, but in this case, even though I'm still going 2 blocks, you have to look at the scale. In this case, you're going to the right, but the value of it is only 2. So it'd be 10 divided by 2. And then that would equal, if we actually simplify it, it equals 5, which then you could convert into a fraction, 5 over 1. You could then label these same way, like the top value is talking about my y-axis. My y-axis is talking about water used in gallons. So this would be 5 gallons. The bottom value is the change in x. My x is talking about time in minutes. And then if you wanted to write a sentence, the rate of change would be, there's an increase, because it's a positive number, an increase of 5 gallons every 1 minute. And you should use water use. So the water use increases by 5 gallons every 1 minute. I'm going to look at one more example really quick. If you extend your axes, all the ones that you're going to look at today are going to start at the origin for finding rate of change, just because it's easier, because then you're just finding from 0 to whatever value. And I'll use the other point. So we're going to go from the light blue dot to light blue dot. So I'm going to go up again to 6. So it's positive 6 because I'm going up. And then I'm going to go to the right. And again, because I'm going right, it's positive. Left would be negative. But in this time, it's going to 4. So change in y is 6. My change in my x is 4. Then if I simplify it, so use a calculator or look, what can you divide both the top and the bottom by? So 6 divided by 4 would give you 1.5. If you convert it back into a fraction using Desmos, you're going to get 3/2, or you could divide the top and the bottom both by 2, and then that would be your rate of change. And then we could label it, so top 3 would be about heartbeats because that's your Y, 2 is about time in seconds. So if we did want to write a sentence, we could say the resting heart rate increases by 3 beats every 2 minutes.